Today is a lot of me talking, so if I talk fast, no. But I also want to talk slow enough that you can understand me. So hopefully we'll be done by like 8:30-ish. 8:45, I guess. This is probably like the most lecture-y I get is this particular class. So. But the stuff we're talking about is really important. So. I actually did an entire semester just on this chapter when I was in grad school. Yeah, not great. Okay. If I drip sweat. You can judge or not judge, actually. I was gonna say don't judge me, but I'm like, if you want to judge me, you can. Hey. You should have your medical or not only. Yeah, right. See ya, have a good night. Alrighty, we'll go ahead and get started. I'm gonna just chat for a couple minutes and then I'll take roll just because there's a decent number of people not here yet. So, a couple different things. One is that today, by the end of class, your group project topics are due. It is totally cool if you handwrite these out, particularly if you're submitting with other folks. So like if you already know who you want to be in a group with, you can just submit one piece of paper for all of you. There's been a couple people, I've been having meetings with folks and absolutely like this makes my day better, honestly, like doing my meetings with y'all. But a couple people have asked me about this. And so what you're looking for your topic is what you're going to create your questionnaire about. So what do you want to ask them about? Is it depression? Is it different facets of personality? Is it their opinion on a specific topic? You could even do something about something political and things along those lines. So use, I think a lot of times when people conceptualize those projects, they come up with like great hypotheses for like a really complex study. And that would be like step 2 after this. What you're doing in this study is you are actually creating the questionnaire you would use in a more complicated study. So what your group topic is what you want to create that questionnaire about. Any questions about that? Yeah.
So it's work that like we're working as a group.
Exactly. And you'll have days where you work on the group project together, or I'll give you like time to work on it together throughout the week. Yeah, if you don't already have a group, just turn in your topics and then I'll group people who are interested in similar topics.
How many people do you want in your group?
Good question. So there's 15 of y'all, so anywhere between 3 and 5 should be good.
After then we'll start to fill out
Yeah, exactly, yeah, and that's why I wanted to go over it last week, because if I'm on top of things, I can send out the groups like tomorrow or Monday. And then if you all want to start contacting each other and get together, you can definitely do that and start working on it. It's not due till fall break, but fall break is gonna sneak up faster than we think. It's about a month away now, which is a little mind-boggling already. So any other questions? We just went over it last class at the IRB, so your group members can fill you in, or I posted the lecture if you want to look it over, so. Yeah, good question. No, I didn't pass it out. I will, however, after the break today, pass out your exam. So this is your take-home exam that you're gonna do between now and next week. Most people have handwritten it, but sometimes people will tell me they just hate handwriting out the short essays, and so they'll type them and print it out and staple it to the back, and that's fine. I do it on the paper because I find that sometimes when people type things, they overthink it, right? Whereas if you write it out, sometimes it flows a little more easy. But just to give you the format, because you know, I'm not passing it out now, so people aren't like freaking out about it while I'm talking. 15 multiple choice, 10 what I call very short answer, and then 3 of those essays. And they're all going to be really similar, the essays, to like activities we've done in class and things along those lines. I try to make these, they're not gotchas, right? They're things that hopefully I've actually taught you, or that are in your reading, so. Alrighty, I think everybody has pretty much rolled in now, so I'm gonna do roll real quick. So Terry, right? Trying to learn where everybody sits. Caitlin, Elijah, Ariana, Caitlin Forster. Yep, there you are. I'm like, we just talked. Day, Emily, Vincent, Julia and Julia, Allison, Trinity, Lisa, Abby, and then Nathan, and Jocelyn. Awesome. I wrote it out for myself, so I don't F it up. Okay. All right, so today I was telling some people who were here early. Today is the day I'm going to talk at you the most, so I apologize in advance for that. But the stuff we're going to cover is really important to assessment in general, but particularly to think about for your group project for creating a questionnaire. So basically, these 2 things, reliability and validity, tell us how good an assessment instrument is. So is it doing its job? And is it doing its job every single time? So this is, like I mentioned, sort of like a longer lecture, but bear with me because this is really important. I actually did an entire semester pretty much just on this in grad school because it's so important to assessment. So let's think about this not in statistical terms, but just in everyday conversation. If you say something or someone is reliable, what do you mean? Count on them? Yeah. Yeah. Yeah, exactly. Yeah, there's someone that you can count on, they're consistent, they're trustworthy. you might even describe them as stable, right? Gonna be able to go to them every time. What if we say, oh, that's a valid point? What do we mean by that? True, right? Or legit, or convincing. And so those, sometimes what we mean when we say stuff in sort of everyday language is completely different than when we mean it in psychological language. But this is not the case here. These translate pretty well to reliability and validity. Thank goodness, makes it easier to remember. So reliability is a really wordy definition for both of these here, so I'm gonna say it a couple times. So reliability is the extent to which a score or measure is free of error. So the extent to which a score or measure is free of error. Theoretically, reliability is the ratio of the variability in the true score. So what that person would actually score if we could just UPC scan their head rather than giving them an instrument, and your measured score, your observed score, right? So no matter how good we make an assessment instrument, it's never going to be perfect because stuff could be happening to that person that day. We might not word it in such a way that everybody's going to interpret it the same way, right? So basically what reliability does is let us look at how close are we on those two scores. So the reliability of that measure essentially is the consistency of that measure. You can count on it. And we use a variety of correlational methods to look at this. And if that sounds foreign to you, don't worry, we're going to explain what that means. But it basically is a statistic that we use to see how reliable something is, in addition to seeing how things relate to one another. So again, reliability is the extent to which a score or measure is free of error. Validity is the extent to which a test measures the quality it says it's measuring. So the extent to which a test measures the quality it says it's measuring. So basically, is this test, assessment, measure, questionnaire, survey measuring what it says it's measuring? Is it measuring what it's supposed to measure? So if I create a measure and I say, this is a measure of hostility, but the questions are like, I feel down most of the day, nearly every day. I have a hard time eating. I have a hard time sleeping. I, just don't want to do things. I might have created a measure of depression, right, instead. So that wouldn't be a very valid measure. So validity is sometimes thought of as the truth or the accuracy of the measure. How accurate is it at assessing, testing what it's supposed to be testing, measuring, assessing? And I think this analogy is really helpful to try to wrap your head around the differences between these. So you can think of reliability as consistent shooting. So whether you're shooting a bow and arrow, skeet shooting, pistol shooting, what have you, rifle shooting, right? Consistency is really important. Validity in this analogy is hitting the bullseye, right? That's what you intend to do when you're in a shooting competition, right? You try to hit the bullseye. The closer you are, the better your score, and maybe you'll win an Olympic medal, right? Who knows? So for target A, this is both reliable and valid. It's very consistent, it's a very close cluster, and it's also right around the bullseye where we want to be. Target B is reliable, but not valid. Again, very consistent, very small cluster, but not that close to the bullseye, right? Probably measuring something different than what we're saying we're measuring. This is hostility, and these are the questions about depression. And then target C is it's not reliable or valid. And let me move the closed caption so you can see it a little bit better. There we go. And so you can see it's kind of all over the place, not hitting the bullseye at all. Some of them aren't even on the target, right? So what we're shooting for when we're creating your questionnaires for your group, certainly when we're creating a measure we're going to use for clinical purposes, like someone's intelligence or someone's diagnosis, is this. We want it to be both consistent, kind of all getting at the same idea, and we want it to be measuring what we want it to be measuring. So both consistent, reliable, and valid, hitting that bullseye, hitting what we mean to be measuring. And this sounds great, but it actually be hard to get here, and it takes a lot of research to do so. And so I just mentioned correlation in passing, so we're going to talk about the correlation coefficient very briefly, just because it'll pop up a lot when we're talking about this stuff, and eventually y'all will actually run correlation coefficients for your data you'll collect. And I'll get you there, don't worry, I'm gonna walk you through everything, no sweat. So correlation is the statistical expression of the relationship between two variables. So the statistical expression of the relationship between two variables. So it can be two sets of scores, it can be two observations you make, it can be a score on a test and a classroom observation, for example, but it's just how do these two things relate to each other? So a positive correlation is as one variable goes up, the other variable also goes up. So let's say we're measuring, my typical example I give here, we're measuring depression and stress. As people are more depressed, they might not be able to do as much as they want, so they get more stressed out. Or sometimes if you're really stressed, right, that might lead to you being depressed. Correlation does not imply causation, is an important sidebar here. So if we say two things are related, we can't say one of them causes the other one. This is where a lot of people on the news screw up. They'll get a correlational study as results and they'll be like, this just in, eating chocolate will add 10 years to your life. It's like, that's not really what that study said, right? So we have to be careful in how we talk about this. This is sometimes referred to as a direct relationship. A negative correlation is as you increase in one variable, you decrease in the other, or vice versa. So the idea here is, let's say again, we'll use depression as an example. You get more depressed, you just don't feel like doing anything, so your activity level goes down. Vice versa, what can happen is your activity level goes down, and because you're not doing stuff you enjoy as much, you start to feel more depressed. And in fact, in depression, it's often both those things together. And this is called an inverse relationship. But basically, a positive correlation is both variables go up. Negative correlation is one goes up, one goes down. Zero correlation means there's absolutely no relationship between the two things. And statistically, if we're representing a positive correlation, it would be a number between 0 and +1. If we're representing a negative correlation, it'd be a number between 0 and -1. And so here you can see this broken down a little bit more. A number between -1 and +1 indicates the direction and strength of the relationship. And this is technically called the correlation coefficient. You'll usually see it represented as R. Okay, and it's a lowercase r. So as R approaches +1, the strength of the relationship between those two variables increases in a direct and positive way. So that relationship is stronger. As R approaches -1, the strength increases in an inverse and negative way. So it's just as strong a relationship as the positive correlation, it's just in the opposite direction. And as I mentioned, as R approaches 0, the relationship is weak or sometimes even non-existent. So at 0 itself, there's just simply no relationship at all between these two variables. All right, so these are some rules of thumb that people put out in terms of thinking about the strength of correlations. So if you're not at 0, but you're between 0 and like 0.3, either positive or negative, that's considered a weak correlation. -4 or -0.4 to -0.6 or +0.4 to +0.6, you're kind of in the medium level. And -0.7 or just to say 0.7 in either direction to 1 is strong. That being said, it is very rare we get these in psychology, just because there are so many different things that go into two variables relating to each other. We usually try to live in this space and we're good with that. If someone publishes that there's a correlation in this range, people will say, yeah, those two things are related. Oops, sorry. Just realized I had a little graph for illustration here. So you can see again, this is the weakest correlation, and then it gets stronger the closer you get to 1 in either direction. And this way is direct, and this way is inverse. Sometimes, just because we know that negative numbers are smaller than positive numbers, and the way we typically think of numbers, people will think negative correlations are weaker. But the sign in front of the number almost doesn't matter. That's just telling you the direction of the relationship. It's really how close to 1 or 0 it is. All right, so here are a couple examples here where we might have some data. People really like to look at the relationship between SAT scores and college GPA. If they're like, this is the reason we give the SAT, it's gonna predict, it's gonna be great. We'll talk about the reasons why that isn't always the best. And then we might look at something maybe more practical. How many classes did you miss that semester? And what's your GPA? Right? So maybe if you're missing more classes, you're missing material, and you're not going to do as well. And so what we can do with columns of data like this is we can turn them into correlation coefficients. So you do a bunch of calculation magic, and what you find is that it's a correlation. There is a relationship. It's in that medium range for SAT score and college GPA. It is direct. So the higher you score on the SAT, in theory, the higher you're going to score on your college GPA. Again, you do your math magic here. And what you find is the more classes you've missed, the lower your GPA. So as your number of classes missed go up, your GPA goes down, or vice versa. Here we're in the -0.67 range. So we're starting to get to that like strong correlation, right? And that probably wasn't surprise anybody in here. Yeah, you miss classes, you're going to struggle. You can also do what's called a scatter plot. And this is where you plot the sets of scores from the previous examples, or any, sort of 2-column data onto a graph. So you can put the SAT score on the x-axis and their GPA on the y-axis, and do this for each person. And this is called a scatter plot, where you create a dot for each person. And so here you see the SAT and GPA one. And here you see the missed classes and GPA one. And one of the things we can do with correlation with these scatter plots is imagine we drew a line through this, right? And we can see, oh yeah, this line is going up. As one increases, the other increases. And this one, the line is going down. As one increases, the other decreases. And so that allows us to look at this in sort of a different way. What's the problem you might see with the SAT and GPA one? What's missing from that scatter plot? Exactly, you're missing all this, right? Yeah, and part of this is because of the nature of the measures themselves, right? I think you get like 200 points on the SAT just for putting your name on it, I've heard, right? So, like, you can't go down to 0, right? Unless I guess you didn't take it, but then that's different. And also GPA, same way, like you can't go to 0, but most people kind of cluster the 1 to 2 and above range, right? The other issue is who gets into college? You're with higher GPAs and higher SAT scores, right? So some universities will even have just like, there's a cut point. And if you're under this SAT score, they just kind of throw your application out. And that's actually a lot of the way that GRE is used for grad schools. Is because they get so many applications, they just use that as a cut point and look at the people above. So you're only getting the people who are doing pretty well, right? And so you're limiting your ability to really address everything. And so this is called a ceiling effect, because you're kind of bumping up on the ceiling, right? You can only get so high in SAT score, you can only get a 4.0 max GPA. Plus, we've eliminated all the people who might have scored poorly on the SAT. And so this is one of the reasons why a lot of social scientists in general, but particularly psychologists, are arguing against using tests as an admission criteria. Yeah, we're finding this relationship, but it's sort of on the weak end of medium, and we have very limited range, so we don't actually know. I mean, maybe someone who scored a 400 on the SAT could get a 4.0 GPA. They just test really badly, right? So these are things that we need to think about from a psychological point of view. It's not just who the numbers show a relationship, but what story does that relationship tell? There's also something called the coefficient of determination, or the shared variance. And you just take the correlation and you square it. It's not that technical, right? You literally, like, if it's 0.80, you square it, and your R squared is 0.64. But what people have interpreted this to mean is that it's a statement about the factors that underlie the variables that account from the relationship. So the idea is we're kind of really looking at the strength of that relationship and how much we're explaining about each variable. So the correlation between depression and anxiety is 0.85. That means their shared variance, so like what goes into causing both of them, basically, is 0.72. So just thinking about it, what are factors that can underlie both depression and anxiety for folks? What can make you anxious, depressed, stressed? Work, yeah. Schoolwork, yeah. Money, oof, money is maybe the worst one. It's yeah, your social relationship, if you don't have friends, or if you're fighting with your friends or your spouse, right? I heard something over here too. Oh, I said finals week. Finals week, yeah. Oh, this is actually a fun little tangent, but I saw a talk in grad school where they talked about health and stress. And they took medical students with their consent and gave them like little tiny cuts, but on their tongues, because the mouth actually heals faster than other parts of the body. And they did it at just like a normal time in the semester and then during finals. And the cuts actually healed more slowly during finals week because of the stress. So our stress also relates to our body as well. That also makes you think, like, if you have any kind of illness, right, that might underlie both of those as well. When I was on my residency, I worked with people who were being diagnosed with multiple sclerosis or breast cancer, or who had just had a spinal cord injury, right? Those types of things can also make you feel both depressed and anxious. Sometimes it's biological, right? There are actual biological conditions that can cause this. So like if your thyroid is off, if you have a heart condition, it can cause symptoms that look like these. Postpartum, it's very common to both postpartum depression and anxiety, which is due to the hormonal peaks and valleys and all that fun stuff you get. So it makes sense that there's a lot of shared variance between these two things, right? Because a lot of the same things can cause it. And this just gives you that idea, that like the majority of what is going on is shared by both. Not shared Bible, shared by both. Nope, really wants to say Bible. Okay, there we go. All right, so now we're gonna start talking about reliability in a lot more detail. Oops. All right, so as we said before, reliability is consistency, it's the repeatability, and we can talk about reliability of a measure. We can talk about reliability of a construct, and a construct's just a fancy way of saying like an idea or a concept. We can also talk about reliability of results of something. So are we gonna get the same score on an intelligence test if I gave it versus someone in California gave it? The reliability is a measure of the consistency of that measure. So we want to know, does our measure get the same answer every time? And every time can mean different occasions of testing. It can mean different people taking it who all have the same level of that concept, or different items on the same test. So test score theory can be a little bit hard to wrap your head around just because we don't tend to think of things in quite this way. And it comes from the idea of error. And as I mentioned previously, because humans are really complex, there's always going to be some amount of error when you do psychological research or psychological assessment. A lot of research involves assessment, so I'm going to kind of use those terms interchangeably. Humans are really complex. Depending on what's going on with them that day, they might not be able to give as accurate a response as they would want to. So part of our job as psychologists is to account for that error, to figure out what it would be, and basically consider that when we're talking about our scores. So the basic part of this theory is represented by this equation where x equals t plus e, or if you kind of flip it, x minus t equals e. And you're like, what the heck does that mean? Well, here x is your observed score. So again, the observed score is the score you're going to get on your assessment instrument. You give someone an intelligence test, you get a 100 for their full scale intelligence, that's your observed score of their intelligence. The t is the true score, what they would actually get on that test if it was a perfect measurement and it was a perfect day for them to be tested. So maybe their intelligence would actually be 105, right? But we got 100 because there's E or error in there. So this is basically saying that the true score is equal to accounting for this other stuff, or that the error is equal to if you take your observed score and subtract the true score. So this kind of relates to some of the big questions we have in life. So why on earth do we give you all exams anyway? We just said finals are like the most stressful time. You can't even heal properly. What do you all think? Why do professors make you take exams? Exactly. Make sure you're retaining information. That's part of it too, right? Like, am I actually conveying it in such a way that y'all can give it back to me? Yeah, and I don't do this in the same way, but some professors for that reason will give lots of little quizzes to see like, okay, what do I need to go over more the next day? Yeah, I think that's such a good point, right? It's not just to torture you. And as I mentioned previously, If I created a device that could just look into your minds and identify your true knowledge of what I've taught you, I wouldn't have to give you an exam. It would also be very creepy, right? I don't want to be that creepy. I probably don't want to be creepy at all, to be honest. And the true scores would still vary, right? Because some people are gonna already have had this information in another class. Some people just absorb things better. Some people will be much more interested in the material than others, and other people will just be having bad semesters, right? Something's going wrong with family or friends or their sport or their job, and like that gets in the way of them being able to do as well. And I don't do it not only not to be creepy, but also just because that thing doesn't exist, right? And as we just mentioned, maybe we don't want it to. There's no way I can actually measure your true score on any test, whether it's an exam, an IQ test, a personality inventory. So when we give an exam or an assessment instrument, what we're doing is getting an estimate of what you know, or an estimate of your personality, or an estimate of your IQ. And that's why the X in the formula we just looked at is that observed score. So whatever scores you all get when you turn back in your exam 1 next week and I have tests to grade it, that will be the observed score you get. It won't be your perfect true score, because maybe I didn't ask about something you really knew a lot about, as much as I try to cover everything, all right? Or maybe I worded a question weirdly, or maybe you just didn't have that much time to work on the exam because of other stuff that came up, right? The degree to which observed scores reflect true scores is going to vary considerably. Some tests will do a much better job measuring how much you've retained. Some people will do a better job on some tests versus others. So who can think of a time when you got an exam, you get your grade, and you're like, this really didn't reflect what I do? Yeah, probably most people, right? For me, it was like chemistry in college. I don't know what the chem professors are like here, but it's like they purposely, like my organic chemistry professor, the average on his exams, they were scored out of 50, would be like a 26 or a 27 out of 50. I mean, and luckily for me, he'd make that a B, because that's where I scored with the rest of the class, right? It was the first time I was like failing everything, and I was like, I don't know what's happening, right? So that's one philosophy. Whereas, you know, my philosophy is trying to measure what you actually know and what I've taught you. So your observed score in those cases wasn't reflective of your true score. And that can happen. And so this is something we can ponder here about all the reasons why an observed score on an exam might be higher or lower or different in some way from their true score. And let me see, yeah, hey, there's a box of chalk. Not just the little tiny broken pieces, but equally this in this room. Okay. And so what we're gonna do is we're gonna write this on the board together to think about what are the characteristics of these different elements. So the test itself, the test taker, the environment in which you take the test, and how the test is scored. All right, so let's start with the test itself. What are some examples of things that can make a test not an accurate representation of what you actually know? Yeah. Yes. Language is huge, right? If I write something and you're like, I don't even know what she's asking me, right? And I've done that before, admittedly. I try to fix it. Yeah, time, right? And I made this mistake a couple years ago. I thought, actually, it might have even been in this class when I taught 202 for the first time. This was my third exam. No one could finish it at a given time. And it was me. I effed it up. I made it too long, right? That can happen. Further examples. Like the content, maybe, right? So maybe I say, oh, this is from my lectures and the book, but then I only ask you questions I didn't cover that are in the book. Right, that's not very fair. I try to do a mix. I try to cover most of what's in the book. Now in the exam, there'll be at least one multiple choice question I didn't cover in class, but most of the things are overlapping. So those are just some examples, right? How about of the test taker? What are some characteristics of the test taker that could influence their observed score? Right, if you're barely awake and you're trying to take an exam, not gonna work, and I'm gonna put with that as an eating disorder researcher, hungry, right? If you didn't adequately fuel your body, that can make it really hard to concentrate. Motivation. Stress, motivation. Yeah. Yeah, but motivation, there's actually something called the Yerkes-Dodson curve, just a bell curve. And it's basically your anxiety or stress versus how well you do on the test or the task in general. So like, let's say you're so stressed out, right? You're so over motivated that you study for an exam for like 24 hours straight, right? You might get in there and just blank out and get a 0 on the exam because you just overworked yourself, right? On the other hand, let's say you were just like, that test will be fine, right? You shouldn't study at all. No anxiety, no motivation. You can also end up with a 0. And the idea is that somewhere in the middle, some motivation, some stress is going to lead to you having the best score, the best outcome. Anything else people think of over here? I would put illness, right? I had surgery in grad school, and I had an exam like 3 days later. And I told my professor, and she said, "Oh my gosh, we can reschedule it." And I was like, "No, I don't have any room in my schedule. I wanted to let you know I might be like loopy the day of the exam." But what I ended up doing is not taking my pain meds, because made me able to concentrate, but also made me in a ton of pain. I did fine on the exam, but I sure didn't feel like it in the moment, right? And I certainly didn't do as well as I could have usually done. Alrighty. Let's think about the environment. So let's say I was giving you all an in-class exam. What are some things in the environment that could influence how well you do? Eat. What was that? Eat. Like right now? Yeah. Definitely sweating. Yeah. Volume, yeah. One of my favorite things was giving an exam in the middle of the morning when they know classes are going. They're leaf blowing right outside my class. I just wanted to throw things at people. Yeah. General distraction. Yeah, yeah. People walking by, birds tweeting, lights flickering in here. At least the ghost lights, they go on and off by themselves. If you feel safe. What's that? Oh, she feels safe. Yeah, that's huge, right? So this could be, you just had a school shooter recently. You're not gonna feel safe in that. It could also be more individual. You've been attacked by someone on campus and they're in your class, right? Yeah, definitely, yeah. You're taking a test with 3 people. Well, not gonna be as many distractions as if you're taking it in a room of 500 people, right? Which happens at bigger universities.
The time you think it.
Yeah, time of day, right? I mean, there's like, depending on the person, any time of day could be bad, right? So like, some people are really groggy first thing in the morning, other people are most groggy right after lunch, right? So lots of these things could go into it. I guess this goes under like general distractions, but I remember one time I was giving an in-class exam. It was a time of the year where the crud was really going around. And there were like 3 or 4 people coughing and sneezing, and one person kept leaving to throw up. I was like, oh my God, just go home, take it later. Dr. Stoley, who poked her head in here earlier, had Lysol in her office. I had Lysol exams for the sick people, so I didn't get it. Yeah, all those things can go into it. How about scoring? What are ways that scoring the test can make it different than your true score you should be getting? Yeah, yeah. So bias. And in fact, most of the time what I'll do is, if you notice your name's on the first page and all that's on the first page is, multiple choice. And so like those are right or they're wrong, right? And then I'll turn the page and I'll put everybody in a stack and I'll like do all this page, do all this page, do all this page. So that I don't have any bias, because I don't know who you are after that first page.
I would say grading scale.
Yeah, yeah. Yeah, so things like. Sometimes tests, and I think the SAT is one of these. They like penalize you for guessing. So if you get a question wrong, it's not just that you get a 0, you get like a negative something too. I am not that, guess away. It's so much better to guess and like have a 1 in 4 chance than to get a 0, right?
They also do grading scale for like a curve.
Yeah, curve is a big part of it. I usually don't curve, but I know other people who do, right? Yeah, oh gosh, yeah. Yeah, there are times I've been grading something and I realized like. There are 2 answers on the multiple choice that are right. So often what I do then is I just give everybody the point, whether they chose one of those 2 or chose a different one, just because the question was written incorrectly.
Time constraints.
Yeah, exactly. If I'm in a hurry, right?
Or like just the test, but like the types of questions that are asked.
Yeah, I think it can kind of go both, right? Yeah, I think that's a good point. Yeah, something like multiple choice, it usually is wrong or is right. Essays, you know, I use a rubric when I'm grading them, but they're still kind of subjective, and some people are really subjective when they're grading essays, right? Like I've had professors tell me, I just like feel when a test is a A or a B, and I'm like, that's not scientific. Like, 8 points. But that's my psychologist brain going, and because I'm taking courses like this, right? Yeah, so there's all these different things, and I'm sure there's plenty more we didn't even think of that can cause error and cause that difference between the actual score you would get if everything was perfect and the observed score, the actual score you get on that test. And one thing I should say actually really quick is that sometimes it leads to people getting too good of a score, right? I'm never going to penalize you for that. But I've had students come up and be like, you marked this right and it was wrong. I was like, well, I'm not going to take the points back, right? But like, sometimes human error happens for that too. So variation can reflect true score variation in and of itself, where there is actual variation in how much students know, right? That does exist. Otherwise, we'd never need to give tests because everyone would just score the same on everything. But there's lots of things, as we just pointed out, that have nothing to do with how much you actually know. And that's the error. The variation in observed test scores reflects both the true score variation and the variation in error. And so that's where you get this formula, right? The central question that we're asking when we're looking at reliability of a test, how consistent is it, is what proportion of the variation in the score we actually get, the observed test score, can be explained by the true score, and how much is because of error. So we get this observed score, how much of that variation in observed score, let's say, you know, we have range in here from a C- to an A+ on the exam. How much of that variation is actually to do with how much each student knows, and how much of it is to do with all this other stuff, right? Because even when you're taking a take-home exam, right, you can have variation in the amount of time you have to work on it. You can have variation in whether or not you have access to a distraction-free environment or a safe environment to work on it, right? So on the next slide, we have a pie chart. And here is a really good test, right? Test A. And so this is where 90% of the variation is true score. So we're like 90% accurate at getting at what students actually know. But there's 10% error because of all the stuff we just talked about. But maybe we have a test like test B, where only 65% is actually the true score, and 35% of the difference between student scores is because of all this error stuff. So if test A and test B were exams for your classes, which one would you rather take? A, right? Because it's going to show what you actually know. Yeah, it will show your knowledge more accurately. And in fact, test A is therefore more reliable than test B because it's better at measuring that variation in the true score. And the proportion of the true score variation, again, whether it's 90, whether it's 65, whether it's this was flipped and the true score was only 35, that would be bad, right? That proportion can be expressed as a reliability coefficient, and that ranges from 0 to 1. And so again, if we're to go back and look at this, then test A's reliability coefficient would actually be, maybe not surprisingly, 0.90, right? It means that 90% of your observed score is actually reflecting the true score. And when we give tests in a clinical setting, again, we're going to diagnose somebody, we're looking at their intelligence, we're looking at their achievement. We want tests in this range. We want to be pretty darn sure we're getting as accurate as possible. Because if not, there's a whole host of problems that could come up, right? You're misdiagnosing someone, you're doing it for court, that's going to get, brought up, and you're going to be seen as incredible. And so obviously the one for test B would be 0.65. And that means it's only 65% accurate at measuring the true score variation. So it's not explaining it that well. So if a test were oh yeah, go ahead.
All right, I just have a question, because you have the true score of error variation before the observed score. So in this case, the whole pie is
The whole pie is the observed score. Yeah, really good question. Yeah, so this whole pie would be your score on the exam, and if it's not a very well written exam, 65% of your score would represent your true score, but there's all this other error that's bringing your score down typically. Yeah, good question. Thank you for clarifying that. So if something were perfectly reliable, if we were able to limit all the error, what would the reliability coefficient be? 1, exactly. No error, basically. And if the test were completely unreliable, what would its reliability coefficient be? 0, yeah. And so it would tell you there's basically no true score factoring in there. We don't want to create a test like that, right? We want to be as accurate as possible. So we're going to start talking about the type of error we try to control when we're assessing people. And that is measurement error. And that's related to reliability in a lot of different ways. Basically, when we're talking about measurement error, we want to know how much unreliability is in the measure. Any factor that creates inaccuracy and inconsistency can induce measurement error. So this type of stuff, right? And in particular, stuff about the test itself is really where we focus in on measurement error. Alrighty, so let's do an example. So who knows what the 40 is for football players? All right, my non-sports people. Some people are nodding. It is how fast they could run 40 yards, right? And you would think something like that's pretty objective, right? It's just how fast they're running. Well, there's lots of different examples of measurement error that can come in there. Like we talked about before, bias, right? So if someone thinks someone's gonna be fast, they might be quicker to click off when they hit that 40-yard line, right? Whereas they think like, oh, this person's gonna be slow, they might be a little more blasé. And maybe it's only a second difference, but when you're running only 40 yards, that second can make a big difference, right? It could also be what type of turf are you running on, right? Are you running on the grass? Are you running on artificial grass? Are you running on cement? Right? Are you running on the spongy stuff they put on tracks? Are you running in track shoes? Are you running in football shoes? If you're on turf, do you have spikes so you can actually not slip and slide? And we can also look at things about the person, right? Sometimes when you're nervous, that makes you speed up, right? But sometimes when you're nervous, that makes you mess up and slow down, right? So you're not as quick off your block. This is why even in things like the Olympics, right? When you watch the finals of track events, there will always be someone who false starts, right? And it's because you've got all this adrenaline built up and you think, oh yeah, I heard the starting whistle when it hasn't gone off yet. It's happened in swimming too, right? So if we think about maybe reaction time to something. So one of the things that we look at in psychology when we're doing particularly like cognitive research is we'll have a person look at something on a screen and it's like, let's say, hit this button when you see an A and an L, but not if you just see an A or not if you just see an L, right? Maybe this person accidentally hit it, but then they're like, oh, that's right. Right? So like that shows a faster reaction time than they would have had. Maybe on the opposite end, they zoned out and they missed one, or they was really slow because they zoned out, right? I have a paper I published about reaction time actually, and it was my dissertation study. And we had people fill out questionnaires multiple times a day, the type of research method called ecological momentary assessment, assessing someone in the moment in their natural environment. And we realized we couldn't use the first screen for reaction time because it was like, that's what popped up when the alarm went off. So it might take them a minute to fish it out of their bag and pull it up, right? Whereas the second screen was a much better reaction time measure, right? How quickly they can respond to something on the second screen. They're actually paying attention. They're not digging it out of the bag, things along those lines. Maybe they're presenting the stimulus really quickly and you just blinked and totally missed it, right? That can happen. Or maybe suddenly you get more motivated to do well. Maybe all of a sudden halfway through the researcher says, hey, got some candy if you do well, right? Or, you know, if you do well, then you pass out of this for class. Or one of the most interesting things I think you find on assessments for concussion protocols. So what they'll do for concussion protocols for sports is they'll test you at the beginning of the season, and then if you do get a concussion, they'll test you again. And what they find is people often do better after they get a concussion because they're really motivated to be able to play again, right? Or they blew it off the first time, right? They didn't care as much the first time. So measurement error, not surprisingly, as we're talking about all this, measurement error reduces reliability. And so we don't want it, right? But we know that it's going to exist. It's an inverse relationship. So as measurement error increases, reliability decreases. It's that negative correlation. So at the bottom of this page is an example of just a negative correlation. And this specific inverse relationship or negative correlation is one I found online. It's a guy named Matt's graph of the inverse relationship between his level of employment and how many posts he makes on his blog. So as you can see, when he has no job, he posts less, or it could be he posts more and loses his job, I guess. I don't know. Right, if he's doing that instead of working. So how do we deal with measurement error? We don't want it. How do we get rid of it or as much of it as we can? These are the three main ways to deal with it. First, we're going to take lots of measurements and average the answers. We tend to get better results when we use similar questions. So we're going to try to ask questions that are similar and assess the same idea in slightly different ways. So on a test, this is why I give you more than just one multiple choice question, right? And it's also why over the course of semester, I don't just give you one exam, right? I give you lots of different types of measurements, small in class assignments, exams, group project, right? That will start to get rid of some of that measurement error and allow me to start to get a true indicator of how you're doing. Then you also, if we're doing some sort of, let's say, personality assessment, you want to ask lots of different types of people. This will give you more variety of answers, and you end up with less idiosyncratic responses that affect your score. So, I'll give you an example. Probably my favorite Psych480 project anyone ever came up with was an alum who now works for the Georgia Aquarium. And she got 4 stingrays, and she trained 2 of them to do a task. And then she would take one of the other ones and put it in the tank with the stingray that had been trained, and not train that stingray, and see if that the new stingray could learn from watching the stingray that already had the test. So it's social learning, but in stingrays. And it worked. It was really cool. But one of her stingrays was sick, and she didn't realize it when she started doing the trial. So it didn't react and it didn't do the task, not because it wasn't learning socially, but because it just didn't feel good. And so because of that, there was a big amount of error, right? This one idiosyncratic stingray. Unfortunately, if that hadn't happened, I think her research would have been publishable, right? But it wasn't because of that. And that happens. That happens to the best of us. That happens to the most seasoned researcher. Give you another example. I'm a co-author on a project that has more than 100 co-authors. There's like 60 different countries worldwide, 40 different languages that we're looking at the reliability and variability of a measure. When we submitted a manuscript to a journal, we got reviews, we revised it and resubmitted it. We just found out today it got rejected. It's just like, I was laughing, right? Because I was like, if this doesn't get accepted, like what would get accepted, right? If you're talking about variability, right? And trying to reduce measurement error. But we'll just submit it to another journal. It happens. And then trying to use very uniform testing procedures. And particularly throughout the semester, we learn about like intelligence and achievement testing. They are very rigid in terms of what the person giving the test does. They have very explicit instructions. But you can also just think about this in a more nuanced or small way. You want to control as many variables as you can. You don't want the scores to be affected by things such as different test environments. So, for example, if I want you all to learn a list of words and I give you 5 minutes to study it in here at night where it's pretty quiet, but then I give you another list of words and I say, oh, go to the soccer game. I don't know who's playing tonight. Kind of the soccer team is playing. Go to the soccer game and learn on. You got 2 minutes, right? You can do as well. So we also want to make conditions as similar as we can. So this is why testing for diagnostic things is typically done one-on-one in a doctor's office or clinic of some kind. We used to use little like sound machines to make sure we're drowning out extra noise. Really trying to make it as accurate and consistent as possible. So if you have an unreliable measure, it means that you can't show the differences that you want. So basically what it means is that if your measure is unreliable, you can't find what you want to find. You can't get the results you want to find. It makes it just really hard to get good results. I have a publication where I really tried to parse out a concept and be like, why does this concept work this way? And I struggled to find measures of the things I thought made up that concept, and some of those had horrible reliability. Like 0.5 range, and again, we want it to be close to 0.9, right? So like it made it so that I didn't find what I wanted to find, just because of the error in the measure itself. There are some other theories about reliability in terms of how we think about wrapping our heads around the concept of reliability itself. So domain sampling model says that we have to use a small number of items to try to get at everything that could possibly measure the construct we're looking at. So I'll give you an example. There is a scale that's been used, I want to say since the 60s, to measure self-esteem. And like it's still the gold standard. People use this over other more recently created measures. It's called the Rosenberg self-esteem scale. It only has 10 items. There are hundreds of questions you could ask about self-esteem, right? So it's tight, it's concise, and you could, in theory, estimate reliability of the correlation just based on that, and especially if we could magically correlate it with the true score. But of course we can't. We don't know the true score, as we keep saying over and over, right? So another way we look at it is item response theory, and this is used for computerized testing. Has anyone in here taken the GRE yet? Okay, so if you have to take the GRE to apply for grad school, it uses this idea. It's adapted. So this kind of sucks a little, because it means if you start getting stuff wrong, you start getting easier questions. So if you're taking the GRE and you start getting easier questions, you're like, oh no, I'm not doing too hot, right? But if the questions are harder, that means you're doing well. This is also used for other things. So the MMPI that we'll talk about a lot more detail later in the semester, this can be used. So like the original MMPI had over 500 items, and they started, one of the ways they cut the items down is they started using item response theory. And so they'd ask like one question from a subscale, and if the person said no to that, they'd skip all the rest of the items. Now there's 10 fewer items you need to respond to, right? And do that throughout. And so it's like a screening measure, kind of. Again, it's going to cut stuff down for you. There are lots of different ways to measure reliability. I'm just kind of looking forward here. I have a couple more slides about reliability, and then we can break, and then we'll talk about validity. And these, we're going to go over each of these. Each of these is going to have its own slide. So don't worry about scribbling anything down right now. All right, test retest reliability is one that you'll often see when someone is creating something they want to be consistent over time. So you're measuring something like a personality trait that you assume is going to be the same across a person's life. This can also be called time sampling. It's basically how repeatable a measure is. So if you take the same questionnaire or test twice, will you get about the same score? So if I give you the Rosenberg self-esteem scale today and I give it next week, will your score be pretty close? Or I give you an IQ test now and you take another one in 5 years. For test reliability to be true, your score should be pretty darn close. Same thing for someone running the 40, right? If you have them run it 3 times, those times should be pretty close to each other if they're consistent. How similar your answers are if I ask you an essay question 3 different times. Essentially what this means is the measure repeatable? If differences do pop up, those could be due to actual differences, or more likely, again, if it's you think it's consistent, that this should be measuring the same thing, it's probably due to error, right? Other stuff going on. And the way you would measure how good your reliability is you just take the score from the first time the person took it, the score from the second time the person took it, and you correlate them. Now, interestingly, there are some times you don't want this. There are some measures you don't want to be the same. So for example, let's say you're treating someone from depression and you measure their level of depression every week. Well, if you're treating them, you hope that's going to start to go down, right? So if that stayed the same and it didn't vary as their symptoms actually varied, that's not good, right? You also can have what are called practice effects. So let's say someone took an IQ test today and took it in a month. They might do better on it just because they'd already seen the type of questions, right? And so we have to be really careful about that if a person is tested more than once. Because again, we want to try to minimize that error. So things that are repeatable, things like reaction time, IQ score, your GRE score, unless you like take a course or something to boost your score, your personality. Things that are not repeatable, if I measure the temperature once a week downtown in Norfolk, right, that's gonna change. I listen to the Outer Banks Speech 104 station sometimes in the morning, and today they were like, there's a record high in Hatteras of 90 degrees yesterday. And at first I was like, that's not a record high, and then I realized, oh, but it's, you know, halfway through September, right, or at least a week into September, so that probably is a record high to be 90 at this point, right? Levels of hunger at different times during the day, right? So if I asked you right after you ate a huge meal versus first thing in the morning, those are going to look really different. They have closed now, but there used to be a place called Texas de Brazil, this Brazilian steakhouse at MacArthur, the chain. And occasionally we'd go, a group of faculty, and we were always trying to figure out like the optimal way to eat throughout the day so that you were hungry enough to consume a lot there because the food was so good. And one day I just totally effed it up. I'm like, I'll just eat breakfast and then I'll be really hungry. And I got hangry, y'all. It wasn't good. We also bring up the point that some things are traits, or we expect them to be consistent traits that you're going to have your whole life. And some things are states that will change, and we expect them to change. Again, things that stay the same, IQ, personality, reaction time. Things that are going to change depending on the circumstances. Boredom, that might be high for some of you right now. Again, I apologize. This is the most me talking, I promise. The temperature, oh my gosh. Can't wait till it goes back to the 70s, right? Tiredness, hunger. So we only expect trait-like things to have good temporal consistency. We don't expect things that are states to have good temporal consistency. And we choose different measurable intervals based on how trait-like something is, right? So if I wanted to see how your personality might vary over time, I'm going to probably want to look over like 10 years. But if I want to see how your emotions are varying over time, I could probably ask you an hour apart, and it might be different, right? Another way we look at reliability is the parallel forms method, which is sometimes called the equivalent forms method. And so you create two equivalent forms of a test, the same level of difficulty, the items selected the same way, measuring the same attribute or the same thing, and you see, do those relate? Are those reliable? Later in the semester, y'all are going to give each other the R bands, which is a measure of like neurological abilities, neuropsychological abilities. And it has 3 parallel tests so that you can give it to people close together, essentially. Because it's created to measure sort of recovery from things. But this is not used very often. Why do you think that might be? Why don't we create 2 or 3 or 4 forms of every assessment we come up with? Yeah. Exactly. Yeah. I mean, so when I used to teach at Kent State, when I was in grad school, a class like this, I would have had like 90 people in, and you would have been crammed into a big like lecture hall type lecture place. And so I created 2 versions of the test, and I'd have like different color paper for the top page. And to be perfectly honest, they didn't know this, but I just moved the questions around to ensure that they were parallel, right? And I would re-randomize the answers as well. But yeah, if you want to totally write a different test that's parallel, it can be really hard. What's the other thing about doing that? That happens to the researcher or the exam getter? Double the amount of work, double the amount of time, double the amount of money, right? If you're getting paid. So that, yeah, those two are the big reasons why we don't do this, right? It takes a lot of time and it's really difficult to develop 2 or more tests that are equivalent. It's very rigorous. It's a great way to measure reliability, but unfortunately, it's often not practical. The split half method is what it sounds like. You take, let's say you have 20 questions on your questionnaire, you divide them in half, and you compare the first 10, their reliability, to the second. You correlate the 2, boom. You just divide it randomly into 2 halves, you do the first and second half. The second option can be a little bit more problematic than randomly selecting, because you could end up with all the items measuring one thing, or all the difficulty on the first or the second half, especially if you're looking at something like an IQ test. IQ tests start easy and get harder as you work through them, right? So you couldn't just be like, well, we'll look at the ones for the second half, because especially the way modern IQ tests are constructed, typically there are what you call like stop rules. So if the person misses 3 in a row, you don't keep giving them the harder ones. So it's entirely possible that person wouldn't have even taken those, right? Alrighty, and you would estimate your reliability for the split half method, and you could do it correlating it, but it'll underestimate the reliability. Because each half, that's all right, it's only half as long as the first test, and we know from what we just talked about that sampling more items often gives you better reliability. So this is a fancy formula that's called the Spearman-Brown formula. That's not actually as fancy as it looks. Where you just are looking at correcting for the fact that you don't have as many items when you split them into 2. So RSB is just your estimated correlation between the 2 halves of the test if each had the total number of items. So let's say we had taken 2 halves of the test and we had a correlation. I'm just gonna erase so I actually have room here. There we go. And we had a correlation that's been good. We're in the 0.78 range, right? We're in that strong correlation range. And so what we could do is we say, okay, how do we account for the fact that we now have looked at reliability only on 10 items instead of 20? So what we do is we say, okay, our Spearman-Brown is going to be equal to 2 times our correlation, that 0.78, divided by 1 plus that correlation. And because I can never math in my head, I'm going to do it on my trusty calculator. So if I take 2 times 0.78, that gives me 1.56 over 1.78, because I just added 1 plus 0.78. So then if I divide those, it gives me a Spearman-Brown's, the corrected reliability of 0.876, or we could round it up to 0.88. So again, it's not hugely higher, right? But this is the difference between when we look at reliability for things, we'd say a 0.78 is adequate reliability. And we would say a 0.88 is very good, right? So since we want it more in this range, having this correction, being able to account for the fact that when we do a split half, it's only half the length, is really important. All right, the most common form of reliability you'll see in, like, if you're reading a journal article and looking at the measures they talk about, is internal consistency. And in fact, again, when you all have collected your data, we're gonna look at the internal consistency of the measure you all come up with. And so it's calculated using a bunch of different formulas, but basically what it does is do all the items of the test actually measure the same thing? And do all the items actually contribute to the score, or can we toss one out and our reliability will actually be better? Sometimes you'll see this called inter-item reliability. It all means the same thing. So let's say we came up with a liberal versus conservative attitude study. So I love Democratic politicians, everyone deserves free healthcare, people just want a handout, the government should not pay for everything. Blue is my favorite color, I like ice cream. Okay, and this is obviously a silly extreme, right? Okay, blue, maybe you could go with like Democrat versus Republican ice cream, everybody likes ice cream unless they're lactose intolerant generally, right? So, but we can do this unintentionally, put something on there that's not actually measuring what we think it measures. So items 1 and 2 here are fairly liberal, items 3 and 4 are fairly conservative. And so these other two probably not going to be consistent with the rest of the scale. So internal consistency is about how consistent the items are with each other, how much they match up. There's a couple different ways you can calculate this. The KR20 has a big fancy formula you don't need to know, but basically you look at the number of items on the test and the proportion of how people score, things along those lines. The most common one that you see reported is coefficient alpha, and it's represented by the Greek symbol for alpha, which kind of looks like the Jesus fish. And so it is basically you take all of the items and correlate them with each other. There's one big fancy correlation that looks at how much these items are related to each other. Another thing that we have to be careful of is whether we're measuring more than one factor or domain of the same concept, right? So if we go back a couple slides to our liberal versus conservative attitudes, you know, again, we have items measuring liberalism, items measuring more conservatism, right? You could imagine 10 items that are more liberal, 10 items that are more conservative, kind of all mixed up together. So if we're doing that, what we usually want to do is get the alpha for each of those domains, which is what we often call subscales. So an alpha for all the conservative items, an alpha for all the liberal items. Observer consistency is often called inter-rater reliability or inter-observer reliability. And this is the degree to which two independent observers agree on something. So some things we do in psychology, we can't just sit down and like score it with a pencil and paper, right? So for example, we'll talk a lot about the Rorschach later in the semester and different projective measures. Anytime you score these, there's judgment involved as the person who is interpreting the scores. Another example is even something that is called structured, that's what's called structured diagnostic interviews, where you ask people a series of questions that match up to the criteria that diagnose them with a disorder. Even there's some level of interpretation based on how a person answers. So if you're like, do you experience this? They're like, I don't know, I guess some of the time, right? Then you as a rater, as the person scoring it, kind of have to decide if that meets criteria or not. So questions that come up here are people coming up with the same answer? Do different people come up with the same diagnosis of mental illness when they interview the same person? Again, hopefully they do, but you've got error here too. When I was in grad school, I was on my placement year. There was a psychiatrist who worked across the hall who did not believe that unipolar depression was a thing. He thought anyone who had depression was bipolar and they just hadn't had a manic episode yet. This is not scientific fact. In fact, many people never have a manic episode who have depressive episodes. But he would never diagnose someone with just depression. It would always be bipolar disorder. So when I interview that person and they say they've never had a manic episode, I'm diagnosing them with depression, right? And so stuff like that can happen. Do different people with a stopwatch record the same time for the 40 for someone, or again, if someone's faster or slower on the clip, is it different enough that it would make a difference in evaluation? So what do we do if we do have low reliability? Well, one of the things you could do, this is when I was in grad school, I had a postdoc, so someone who had just recently graduated with their doctorate, teach us how to do the MMPI. And one of the things he said is, like, if there's really low reliability or they're just answering in a really inconsistent way, just fold it in a paper airplane and chuck it in the trash, right? So in theory, if a questionnaire you make or an assessment instrument is just really bad, or a test I give that no one does well on, I could just chuck it in the trash, right? But there's actually things we can do to improve it. So we can increase the number of items. The more items, the more likely it is to have good reliability. The same Spearman-Brown who came up with this created what's called the Spearman-Brown prophecy formula. And that basically allows you to say, okay, my reliability is this, how many more items do I need to add to get to a good reliability? And so you can do that. You can also do factor and item analysis. So this is, again, another statistical way where you can look at each question and say, what's it grouping with? And again, maybe here you find out you have different subscales that you didn't realize you were measuring. Or maybe you need to remove some items that don't correlate with everything else. The term they often use is they don't hang with the other variables. You can also do what's called a discriminability analysis, where you examine the correlation between each item and the total score. And again, this will tell you, okay, you can take out this item and your whole reliability will go up. You can also do what's called correction for attenuation, which is just where you correct for measurement error when you score. I think your book has a fancy formula. Don't worry about it. Alrighty, so we will do validity after the break. It's about 7:25-ish, so come back around 7:40. Alrighty, everybody else will circle back in. I'm guessing there was probably a tap to get through this drill. But does anyone need a minute with your group to figure out topics, or people feel good about that? Okay, or individually, you can just write them down. And I'll have y'all turn those in at the end of class. Alrighty, so I am gonna come around with your exam just so I don't blank out and forget to give this to you at the end of class. So again, you have all week to do this. You're gonna turn it back in next week. At the start of class. And if you have any questions, you can just shoot me an email. Oh, have it wrong. That happens. Oh. Oh no, use whatever. I grade in purple, but if you grade in purple, that's also fine. I do grade in purple. There's psychological stuff about grading in red, so I don't do it. Yes, so if you have your topics, you can go ahead and put them in like what we need. Exactly, yep, that's perfect. Alrighty. So I am gonna dive back in and talk about validity here. This one is not as long. Yeah, the reliability one is like a much bigger one. So bear with me. And I know that it's hot and I know that it's yucky. And remember that your exam is also gonna be open book, open note. So you can use that, just not open friend. So as we mentioned before, validity measures or says whether the test measures what it says it's gonna measure. So for example, is this measure of anxiety actually measuring anxiety, or is it measuring depression? Does this test of self-esteem measure self-esteem, or is it measuring narcissism, which is sort of the more notorious version of self-esteem, right? Where you feel too good about yourself. Is the school aptitude test actually measuring school aptitude, or is it just measuring how well you can read? I could expand this. Does the SAT actually measure any sort of aptitude, or is it just measuring how good you are at taking a standardized test? Right, things along those lines. So again, reliability is the consistency. Validity, another way we can say it, is the meaning of the scores. Reliability, however, is a necessary precondition of validity. So if your test is not reliable, it won't have good validity. A test validity coefficient cannot be higher than the test's reliability coefficient. So statistically, in order to be valid, it has to be reliable. But it has to be more than just reliable or consistent. It also has to measure what you think it's actually measured. So how do you demonstrate that a test, an exam, a measure, questionnaire, survey has validity? The process is actually similar to establishing evidence in a court case. In both cases, for example, it's necessary to build evidence to demonstrate the assertion. So to say this is valid, you've got to build evidence that it's actually valid. So what specific questions are you asking when you're doing a study about validity? When you want to say, is this test valid? What are you actually asking? Does the test adequately measure the domain being tested? So are we actually measuring depression? Or we say we're measuring depression, but we're actually measuring anxiety. But if we're measuring depression, are we getting at all aspects of depression? So for example, the Beck Depression Inventory includes things that are part of depression but aren't even part of the criteria. So for example, there's an exam where there's a question about how your depression is affecting your sex life. Not something that we ask diagnostically, but a really important part of depression for a lot of different people. Does a test correlate with a particular criterion or standard against which the test is compared? So if you were building a new IQ test, does your score that you get from your IQ test correlate with something on the standard, the gold standard, the WAIS, the Wechsler Adult Intelligence Scale that everyone said, yes, this is the IQ test? If it does correlate with that criterion, is that criterion a future thing or a current thing? So are we trying to say we're looking at SAT scores and will they predict college GPA? Or are we trying to say we're going to look at SAT scores and how they relate to your high school GPA, which you already have at that point? And does the test actually measure a targeted construct like anxiety or depression? I'm just gonna hide the captions. I feel like they're just gonna get in my way here. And hopefully y'all can understand me. So this is just a fancy way of saying, are you measuring one thing? If you're trying to measure one thing, are you measuring one thing? Are you measuring 5 things? So how is the correlation between a test and a criterion measured? There's a particular type of correlation called the coefficient called the validity coefficient. And validity coefficients can be as high as in the 0.6 range, but validity coefficients in the range of 0.3 to 0.4 are considered good. A validity coefficient is statistically significant. In general, when we say something is statistically significant, and we'll even say this with a little symbol, p is less than 0.05. And what that says is that it's unlikely to occur by chance more than 5 times out of 100. The other way we can look at this is that we are 95% confident that this is the right, that we're actually measuring what we want to measure. There are a bunch of different types of validity, and again, like the different types of reliability, each one of these is going to get its own slide, so no need to scribble these down right now. Base validity, in some ways, isn't a true type of validity because it's not really evidence of meaning. Basically, face validity means on the surface, on the face of it, if I look at this test, can I tell what it's trying to measure? It's a measure of depression. Does it look like these items are about depression? So why bother? Why do we want this? Well, it gives the appearance of validity or meaning to the test taker. If the test taker can read something over and say, ah, I can tell why they're asking me this, I can tell what they're trying to get at, then they can have improved motivation. Alrighty, so I have a quick demonstration. I need a volunteer. I'm going to ask you to do some very simple calculations in your head. So does anyone feel confident in their ability to do that? Everyone's like, no, it's not. All right, thank you very much. Okay, so 2 plus 3. 6 plus 1. 10 plus 5. Told you it'd be simple. Okay, so what was I measuring? Yeah, ability to do math, or we could even say simple addition, right? Great job. Did it have face validity? You could tell what I was getting at, all right? I was asking you to do some simple math. You did some simple math. All right, so let's flip this and think about something else we're all used to. What does a thermometer measure? Temperature, right? Does a thermometer have face validity? Really, right? Because if you don't know what the numbers mean, it doesn't actually tell you anything about how hot or cold it is, right? Just as someone from Canada, right, or other places where they use Celsius, trying to interpret Fahrenheit, right? Or if we tried to interpret Celsius, I remember I flew in one time from the UK and they were like, it's like, I don't know, 30 something Celsius. And everyone was like, oh, because apparently that's hot. I was like, sure, I don't know what that means. Let's go. Right? And so it's not quite face valid. So in terms of thinking about what's more useful and is a better predictor of relevant outcomes, a thermometer, right? I mean, if I was trying to use our simple math, right, that wasn't going to tell us about the temperature. So face validity is not always that helpful. And in fact, sometimes measures will purposely try not to be that face valid because they want to kind of like lie to you, but disguise what they're really getting at. One example of, again, something face value that's not that useful is like BuzzFeed quizzes, or if anyone used to ever read like 17 or things like that, the quizzes in there, right? These are very face valid and they're fun, right? But they're not that useful. Content related validity asks, is the test constructed adequately? Do the test items adequately sample the material being tested? So for example, I just gave you exam 1. It's supposed to be measuring chapters 1 through 3. If I only gave you questions from chapter 1, that would not be good, right? You'd be like, what about all this other stuff we covered, right? Content related validity is logical rather than statistical. That is, it's determined by judgment and not by statistical analysis. So for example, when I construct one of your exams, there are 3 essay questions. There's 1 from each chapter, basically, because I'm trying to make sure I cover everything that we've covered. Criterion related validity is how well does a test score relate to a particular standard or criterion? So again, we keep using this weird word criterion, and we're going to take a couple minutes to explore this. So let's look at several hypothetical tests. So let's say we were looking at like hang on, I'm gonna revise my directions on this. I'm sorry. It's like I feel like my brain is melting. Okay. So I'm gonna give you some examples, and for each one, try to imagine a criterion, a gold standard, something in which our prediction scores could be compared. So for example, a suicide risk scale. What could be the criterion we compare it against to see whether that suicide risk scale is actually doing its job? It's actually kind of. Well, what's like maybe even more obvious one? Whether or not that person tries to commit suicide. Right? Yeah, that's okay. Sometimes the most obvious things you're like, what? Oh, okay. How about a driver's skill test? If someone does well in their driver's test, what should the criterion be? How should they do in their driving career? Good, yeah, you should hope they won't have that many tickets, they won't have that many accidents, right? Things along those lines. Medical professional licensure test. What do we hope that predicts for us? Someone passes. Yeah, they don't have a job. They're gonna actually like try to keep you alive, right? And that they're going to do a good job as a doctor. Consumer credit risk assessment. Right? Credit scores. The idea is if you have a good credit score, we can lend you money for a car, a house, what have you, and we can be pretty sure you're going to pay it back. Right? So there's 2 different kinds, and we're kind of hinting at them as we're getting at this. There's predictive and there's concurrent. And so a lot of what we were just talking about was predictive. And the purpose of the test is to predict how well the test taker will do on some measure of future performance. So for example, some people, when they go through premarital counseling, they'll be given premarital tests for marital success, compatibility. And those are supposed to predict how well you'll do in your marriage. I think our minister knew we were going to be okay in our marriage when he realized we had already talked about everything that he was asking us about. It was so funny because our ministers at the time were a husband-wife team. And the wife said, oh, watch out, he broke up his last 3 couples. And what it turned out is that the last 3 couples he had worked with had all been together less than 6 months. And at that point in time, my then fiance and I had been together 4.5 years. So like, we knew each other, right? Or the LSATs, right? Similar to the SAT. The idea here is that this will predict whether you're going to be successful in law school. Concurrent evidence is when you simultaneously administer a test and a measure of a criterion. And then you statistically evaluate the relationship between those two. And so, for example, let's say we're going to test for learning disabilities, but we're going to use their academic performance and compare to that. So, for example, when I did tests for folks with learning disabilities, you give them an intelligence test, which sort of takes away a lot of the barriers that get in the way when you're in school. You don't have to write anything. So if dyslexia is an issue, that's not going to get in the way. There are problems you have to solve on the spot, so it's not so much about remembering things, right? And then we give them a test of achievement, where you do have to do things like write and read and do basic math. And you compare how they do on the two. And where there are gaps between essentially what they should be able to do and what they are doing, that's where you recognize, there might be like a reading-based learning disability here. So again, you're going to statistically evaluate this relationship between these two. And again, here is where things like using that validity coefficient come into play. And this is actually something that you guys will do again, y'all will do with your data that you're going to collect. Is you're going to have your criterion, that existing measure of the same thing. And you're going to compare the scores you get on your measure with the scores you get on that criterion measure. Construct-related validity is a little bit more abstract of a concept. A construct, as we've mentioned, is like a concept, an idea, something built or constructed by mental synthesis. It's multidimensional, it's non-observable, but it's a thing we can talk about. Depression is a construct, intelligence is a construct. Optimism is a construct, introversion, even something like physical health is a construct, because how you determine how to measure physical health can be subjective, right? Are you going to use blood pressure? Are you going to use weight? Weight is like one of the worst indicators of physical health. Actually, people who are overweight live longer than people who are underweight, right? But like people don't acknowledge that. Right, so all these things are sort of abstract and you have to determine how you're going to measure them. So let's take an example here. Let's take, and I'll use this side, there's a little more space. We're going to take introversion. And again, if you're not familiar with what this concept means, introversion is being shy, basically. So what are things that you think of when you think of introversion? What makes up introversion? Yeah. Quiet, yeah. What's that? Yeah, sometimes this is right to loneliness. And in fact, for that reason, introversion is sometimes highly related to depression scores. Yeah. When you think of someone who's introverted, what do you how do they act? How do they look? What do they do? Anxious, yeah. So social anxiety can be part of this, right? Maybe they're a wallflower, right? At the party. They're the one just kind of sitting by themselves or playing with the dog, right? Not really socializing. Maybe they're not going to participate in class. Maybe they'll drag their grade down, right? In participation-based class. Okay, that's why I spelled that horribly wrong. Don't judge me. But yeah, I mean, we could just put shy, right? So just this one thing, introversion, We got a whole bunch of different things that go into that, into our idea and our understanding of the concept of introversion. And so, you know, someone who's really high on introversion might be completely different from someone who's really low on introversion, right? An extrovert's probably going to feel comfortable in a setting. They're going to be outspoken. They're going to be on the dance floor instead of in the corner. They're going to be getting the high participation grade, things along those lines. So construct validity encompasses all the other types of validity. And construct validity is something that takes a while to establish. So we establish it over time through a series of studies. It involves assembling different points of evidence about what a test means. And in fact, construct validity can be ongoing. And demonstrating construct validity is this ongoing process, is where the construct is gradually defined and clarified. And when I teach theories of personality, we talk about how a lot of the work that's done in personality research is basically construct validity. What happens with construct validity is, okay, you're trying to define a construct so that you can measure it, right? And then you create, let's say, a personality questionnaire to measure it. And then through your research with that measurement, you can redefine parts of the construct. And so this kind of goes back and forth and becomes a cycle whereby we refine our understanding of psychological ideas, and at the same time make better and better measures, surveys, questionnaires, to get at things in a very valid way. So the construct itself is gradually defined and clarified, and at the same time, we're getting better and better measurements. We can have convergent evidence for construct validity. And this is very similar to concurrent validity. And this is when a test correlates well with other tests that measure the same construct. So if I made a new intelligence scale, I would want it to correlate with one or all of these existing intelligence scales. And again, this is what y'all are going to be doing with your questionnaires. However, one of the things we also look at is divergent evidence for construct validity. And this answers the question, why create a new test if an adequate test already exists? What's unique about your new test you're making, your new survey, intelligence test, what have you? You want it to demonstrate low correlations with unrelated constructs and show evidence for what that test does not measure. And so, for example, these tests, each of them, although they're correlated with each other, it's not as high as you might think because they're getting at slightly different things. I'll give you an example here. So one of the things I did with some of my colleagues 12 years ago, something like that, we created a measure for feeling sex. What do you do? What behaviors do you engage in to feel sex? The measures that existed at the time were extreme. They were like, I would be in a Girls Gone Wild video. And it's like very low, like not a lot of people were endorsing it. So you weren't getting a lot of variability. It was sort of the opposite of the SAT, where you're getting a floor effect, where everybody was kind of scoring 0 or 1, right? So we did focus groups and asked people what they did to be sex. It kind of surprised us. It was a lot of just grooming behaviors. It was like, I take a shower. I put on makeup. I think one of them was I put on deodorant. Which was good, I guess, right? But we found that it was correlated with that existing measure, but at a low level, right? Showing that it was measuring something different. So this is another thing y'all are going to do for your group project. So you're creating this new measure. So let's say you create a new measure of, try not to use depression for everything, it's just an easy example, Matt. You create a new measure for, drug use. Okay. So you would want that to correlate with existing scales about drug use. But you wouldn't want it to correlate that highly with measures of like impulsivity, right? Because then you're measuring something more broad, and not as focused. Or maybe you wouldn't want it to correlate that highly with like a measure of depression, because then you're measuring depression and not specifically drug use. So you can kind of conceptualize it that way. So this can become as important as what it relates to, right? What it doesn't relate to helps you really define what this concept is. Both are useful. So we want to see, to what extent does this new test overlap with existing measures? And to what extent does it provide a unique assessment tool that we need, something novel to the field? There are also things called criterion reference tests that contain items designed to measure specific instructional goals. And the criterion here, rather than being a gold standard measure, is often just the number of correct answers you get. And validity measures here would compare the test scores to scores on other measures believed to be related to the test. Now, one thing we need to keep in mind going forward throughout this class, and it relates to what we talked about last week with ethics, is that testing in and of itself is big business. I want to say when I bought a waste kit, it was $1,200. And if I had bought it in the fancy briefcase instead of the box I got it in, it would have been like $2,000. And that's one, right? My training clinic had a stack of them because they needed a stack of them, right? And MMPI, it costs you to buy the test booklets and the Scantron sheets and the book you need to score it. But then if you don't want to score it by hand and you want their service to score it for you, you also pay for each one you get scored. Right? Yes, thank you. That's how I feel. We had always gotten in our training, like we'd always gotten our scoring for free because we used it as part of research. And then one day they just randomly started charging us. And we were like, whoa, because we had no idea. It sort of shocked us all. We got it figured out pretty quickly. Right? So those things can add up. And typically, if you are charging for your services, you roll that into the plan fee. But this makes us concerned about the power of the testing industry, right? Especially when, if you look at something like, let me pull up like one of the bigger testing sites. Okay, so Pearson Assessments, okay? They own a lot of the big tests, right? And they've merged with other people on tests. So they have like graduate admissions tests, like the PCAT and the MAT. They have larger scale assessments, like K-12 graduation assessments, that type of thing. And then they have the professional assessments that you would buy as a psychologist, right? And so these are the types of assessment. This is the giant list of assessments that one company owns. And each of these, they charge for. They charge each person for. And they own things that are technically in competition with each other. So the Millen Clinical Multi-Axial Inventory measures many of the same things that the Minnesota Multiphasic Personality Inventory measures. So it's like, even if you wanted to go the competition, because of how many times things have merged and overlapped and been acquired to different companies, it's like the competition is the competition, right? Like it doesn't exist. So again, like I'll try to give you an example here. The MMPI 3, the most recent version of the MMPI. So just to buy a kit is $127. Test forms and report packages start at $19.50. Support materials start at $37. And then training. So if you want to be trained to use this, if your grad school didn't train you how to use something, or like when they put out the new version of the MMPI 3, it was different enough to the MMPI 2 and the MMPI 2RX that even though I was trained by excellent assessment people, I had to undergo training so I could teach you all about the new version. And they'll charge you to train you. Right? So it is a monopoly, and it is something that we need to be aware of and need to be, again, I want to say it's not malicious, but I guess it's just capitalistic, right? You could take that as it is. But to give you an example, I think it might be different now because UC actually wrote some of the materials for the MMPI 3. But when I was in grad school, Jack Graham, who was one of my professors who helped co-write the MMPI 2, he got no money from the sale of the MMPI 2. It went all to the company. Yeah, and again, since Yoshi's like first author on some of this stuff, I'm guessing he gets some money. Certainly when he did the training I got to go through, I'm sure he got some of that money. He better have gotten some of that money, right? It was pricey. But again, to sort of think about like who is selling it, why are they charging what they charge, what barriers are there to accessing it? And it also, we have to think about the results, right? How we give results, what results people get, and again, fully acknowledging everything we talked about the first half of the class, right? That there is error inherent in no matter how good the test is. I'm going to tell someone your IQ is a 95. It's within the average range. But the average is 100. So someone who hears that is going to think, I'm below average. And what implications does that have for how they feel about themselves, for the motivation they have going forward, for how much they apply themselves, for what they think they can do or they can be. And it can go the other way too, right? You can be like, oh, it's 95, I'll show you. I'm gonna be a doctor, right? They're some of the best doctors, but they work the hardest, right? Also, the ubiquity of commercially available standardized tests in education has led to widespread teaching to the test. And I'm sure you've all experienced this in high school, right? Where they're like, okay, well, this is going to be covered on your SLO, so let's go over it. Right? And oftentimes, like, funding is tied to how well your class or your school or your district does on those tests, right? So then that makes it even more, we got to teach to the test. When my husband, he used to work as a high school teacher. He worked in Georgia while I was there in my residency. And part of his job was to take the kids who didn't do well on their math graduation tests and like work with them for an extra period a day, just so they could pass it, basically. So you've got kids who probably hate math because they're not good at it. No one's ever taught them to do it well. And you're like, you got to take normal math, but also this extra math class every day. Not surprisingly, he didn't get great reviews. I think that's part of why he ended up not being a high school teacher when we came here. But the funny thing is now he's teaching again, because everything comes full circle in weird ways. But he's just teaching people that he works with. Can test scores be used to harm individuals? Yeah, even unintentionally, right? Even something as simple as a diagnosis or a misdiagnosis, right? Can be problematic. If you label someone as having a learning disability, that can have stigma. Or if the person doesn't understand what that means, they might think they're stupid. I think of a client I gave a comprehensive assessment to and gave her feedback that you have a personality disorder. She had some psych educational background. She freaked out on me. She said, oh my gosh, that means you can't fix me. You can't fix personality disorder. She's sort of right, she's sort of wrong. The field has come a long way. But that was harmful to her, to tell her that. to be perfectly honest. I don't know that there was any benefit to me telling her that, but she wanted to know, and so it was like this ethical dilemma. And then the problem becomes, is the problem with the tests? Or the misinterpretation of the tests by other people? Or how we're using those scores? Right, and again, this is where ethics and legality and everything else ties back in. I must have talked super fast tonight because I was hot, because we are done. Woo-hoo. Thank you all for hanging in there. Starting next week, we're gonna be doing more interactive stuff and group assignments, and we'll be eventually going to the computer lab and learning to do things. So thank you for hanging in. If you have any questions, I'll hang out for a couple minutes. If not, head home to where it's hopefully cooler.